What's up, Pokemon Masters? Mr. Cully coming at you with another video, and today's lesson is going to be on dimensional analysis, and it kind of sounds scary. It sounds super nerdy, and you're like, I don't even know what that is. All right, it's going to be okay. It sounds scary. There's a lot to it, but I'm going to break it down step by step for you in case you're having trouble with it. You just need a refresher on it. But dimensional analysis is useful, especially in science class when you get to chemistry or physics, because it has to do with converting units. So in chemistry, we deal with grams, we deal with liters, we deal with a lot of different substances, moles. You don't even know what that is yet, maybe. And so dimensional analysis is a tool that we use as scientists, and really just in math in general, where we get to convert things from unit to unit, and it kind of lays it out really nicely for us. So it's going to start simple and get progressively harder. But the thing is, you're going to find out, Mr. Cully, I feel like I could do some of this, my own way. I don't want to use this method that you're teaching me. And I would say, I get it. You're just like me. I was able to do it my way on my own at first too. But truth is, things are going to get kind of harder and more complex, and you're going to need to be able to use the method that I teach in order to do these problems. So make sure that you understand that the method I'm teaching you is the one that I'm going to be grading you on, and it's one that you're going to need to use throughout this year as we're converting units. So as I said, what is dimensional analysis? It's how to convert units. So I think the best way to kind of dive into this is to kind of show you the format of what it looks like in a sample problem. So let's look at the sample problem. We want to convert 180 pounds to kilograms. All right, pounds is a unit of weight, kilograms is mass, also weight if we're accounting for gravity. So we can convert between the two. Now, in class, I'm giving you a conversion sheet to get between certain units, and I'm going to give you a sheet, and it looks like this, okay? So here you're going to have a conversion sheet where you're going to have mass and volume and length and time and temperature and just a bunch of different units where you can write whatever you want on the sheet to help you remember the conversions between them. So in this previous problem, what we're doing is we're converting pounds to kilograms, all right? So the first thing you do is you recognize, okay, what unit am I starting with? What unit am I going to? I want to convert between pounds and kilograms. So I'm going to look at my conversion sheet and see, okay, where on here does it give me any conversion between pounds and kilograms? And under this category, weight and mass, I see that it actually does give me a direct conversion here. 1 kilogram is 2.2 pounds, all right? So that's what I'm going to write down. I'm going to take that information, and I'm going to write down the fact that 1 kilogram is equal to 2.2 pounds. All right, fair enough. That sounds simple, okay? So once you have your conversion written down, just put that off in the corner somewhere, then we start the actual dimensional analysis problem. This is where we're going to start converting, okay? So it's going to kind of look like fractions. It's going to look mathy. Here's the way that I set it up. You always start with what you're trying to convert. So in this case, it's 180 pounds. So I'm going to write that down, 180 pounds. And make sure you include the units always, 180 pounds. All right. What you're going to do with that number and that unit is you're going to multiply it by a fraction. You're going to multiply it by a fraction, kind of like this. The thing is, what goes in that fraction? Well, in that fraction, you're actually going to be putting that conversion, the conversion that you found. So over here was my conversion. 1 kilogram is 2.2 pounds. So I'm going to input that information into this fraction. You're going to see what happens. Well, I'm going to input it in a certain way. I'm like, okay, well, how do I input that information into that fraction? Well, one of these numbers in the unit will go on top in the numerator, and one will go on the bottom in the denominator. The question is, which goes where? Well, recognize something. You started with pounds. All right, you started with pounds. Whenever you start with a unit, okay, whatever's up here, in order for you to convert that unit to something else, it needs to be canceled out. All right. Well, in order to cancel out something in math, if you remember, you have to have something on the top and on the bottom. Well, like for example, 2xy over x, what does that simplify down to? Well, that simplifies down to, well, just 2y, because these x's cancel. What's on the top cancels what's on the bottom, all right? So keep that in mind. If you want to cancel something out in math, what's on the top has to be on the bottom, and then they cancel out, all right? Well, let's take that information that we learned in math class, and let's go ahead and say, let's put 2.2 pounds on the bottom of this fraction. Since pounds is up top here, we're going to put 2.2 pounds, that's a weird 2, down here. 2.2 pounds And then we're going to put that 1 kilogram on top. 1 kilogram on top. So now we inputted our conversion into this fraction. Now let's treat it like a math problem, all right? So how do you multiply a number by a fraction? Okay, you just multiply the tops and you multiply the bottoms, and then you get some sort of answer. So let's go and do that. If we were to do this with math, okay, we'd multiply across the top. So 180 times 1, and I'm going to be doing this as we go. So 180 times 1 is going to be 180. And then what's on the bottom? Well, the only thing I have on the bottom is that 2.2. 2.2, okay? And, well, what does that equal? 180 divided by 2.2 is 81, about 81.8, okay? Well, 81.8 what? I can't just leave it as a number because then it doesn't make sense. It's got to have a unit to it. Well, here's the thing. We're getting to the point where not only do you multiply numbers, but you actually multiply units too. It's kind of weird to think about, but units can be multiplied together, and in this case, they do. So if I'm multiplying 180 times 1, I'm also multiplying the pounds times kilograms. And so really, this answer is 81.8 pounds times kilograms over pounds? That seems weird, okay? But that's actually true. My unit is 81.8 pounds times kilograms over pounds. But remember, in math class, you can cancel out what's on the top and on the bottom. And just like in math, with units here, if they're multiplied together, divided by each other, if one's on top, one's on the bottom, you can actually cancel them out. So really, what am I left with? I'm left with just kilograms. So my answer is 81.8 kilograms. And, well, that's what I wanted. I want to convert my 180 pounds to kilograms. So I was successfully able to do that, all right? It's kind of a weird approach to it, but essentially this is how it works, is that you set it up like this, it cancels the units, and then you get your final product out that you want, all right? So this is the simplest kind of problem where you only have one conversion, all right? Let's do another example to kind of see how this plays out with new numbers. So let's take 5 kilometers and convert that to miles. So if you ever ran a 5K before, that's 5 kilometers. And let's convert that to miles. Maybe you already know in your head because you're a runner. But let's go ahead. The first thing that we do is we recognize, okay, I'm going from kilometers to miles. So I'm going to go look at my conversion sheet, and I'm going to say, okay, where on here does it give me anything between miles and kilometers? Well, I have over here that 1 mile is equivalent to 1.609 kilometers. Fair enough. That makes it easy. So I'm going to write that down here in the corner. 1 mile equals 1.609 kilometers. All right, I'm going to use that. Now that I have my conversion written down, I'm going to set up my problem. I'm going to take what I was given, what I'm trying to convert, the 5 kilometers, all right, and write it right there. I know I need to multiply that by some sort of conversion, some sort of fraction. Well, what goes in that fraction? The conversion that I had. So I'm going to input this again into this fraction. And the question is, well, what goes on top, what goes on the bottom? What goes in the numerator, what goes on the denominator? Remember, if I want this kilometers to end up canceling out in the end, then I'm going to have kilometers on the top and the bottom. Well, right now to start my problem, I have kilometers on the top, which means I'm going to have my kilometers on the bottom in my conversion. So I'm going to put my 1.609 kilometers on the bottom there and my 1 mile up top. And so now I just got to do the math, right? So 5 times 1 is 5 divided by 1.609. And let's see what I get. 5 divided by 1.609, and you should get 3.1. 3.1. But what's my unit going to be? Well, right now, I could recognize that if I were to multiply my units across, I'd have kilometers times miles divided by kilometers. My kilometers are going to end up canceling because one's on top, one's on the bottom. So really, what I like to do is I don't want to go through and multiply all that out. There's no point. I know it's going to cancel. So I go back to my problem and I actually mark it off there. I know my kilometers are going to cancel because I had one on top and one on the bottom. So really the only unit that I'm left with that didn't get canceled is miles. So my answer is just 3.1 miles. All right. And that's what I wanted. I wanted to convert 5 kilometers to miles. And so if you ran a 5K before, you actually ran 3.1 miles. All right. So that is the setup for this kind of problem. Well, it does get a little bit more challenging. Let's say that we have this problem. We want to go from 2,000 milliliters to cups. All right. So again, first thing we do is we say, all right, is there a conversion between milliliters and cups on my conversion sheet? And I look and I say, okay, well, cups is down here. Milliliters is up here. Okay, milliliters to cups. It doesn't look like I have any conversion. All right, there's no direct conversion between milliliters and cups. So the question is, what do you do now? What do you do at this point? Well, you kind of have to use your head a little bit. You got to say, how can I get from milliliters to cups? Well, you could recognize something. You could say, all right, I got milliliters, and I can go from milliliters to liters because I know that 1 liter is 1,000 milliliters. I remember that from the whole metric system unit. Okay, 1 liter is 1,000 milliliters. All right, does that help me out? Well, if I can go from milliliters to liters, then I can also convert those liters to quarts. Okay, fair enough. So I can go from milliliters to liters. I can go from liters to quarts, but I'm still not yet at cups. Well, I can go from quarts to pints, and then I can go from pints to cups. All right, so I can get there. It just takes more than one conversion. Is that okay? The answer is yes. It just gets more complicated that way. So let's go ahead and think about, we got to write down each of these conversions and we'll see how it plays out in the problem. So let's write down all of what I just needed. If I'm going to go from milliliters to cups, I said that I need to know that, and I'm going to write it down here, that there is 1 liter. 1 liter equals 1,000 milliliters. I wrote down that 1 liter is 1.0567 quarts. I also wrote down that 1 quart equals 2 pints. And I wrote down that, I'll write it over here, 1 pint equals 2 cups. All right, so using these 4 conversions, I should be able to get from milliliters to cups, okay? So let's see how this plays out. Again, you always start with what you're trying to convert. So in this case, I'm trying to convert my 2,000 milliliters. So let's go ahead and write that down, my 2,000 milliliters. And I'm going to multiply that by some sort of conversion. Well, I recognize that I'm going to have to do multiple conversions here. So the first step that I think my pathway here is I'm going to go from milliliters to liters, liters to quarts, quarts to pints, and then pints to cups. So my first conversion is going to be from milliliters to liters, okay? So this is going to be my first conversion. This is what I'm going to put in this first conversion, all right? And again, what goes on the top, what goes on the bottom? Well, that depends. What did I have on top before? I had milliliters on top before, so that means that on the bottom, I need to put my milliliters because I eventually want that to cancel. All right, so the 1,000 milliliters goes on the bottom, and the 1 liter will go on top. All right, fair enough. But here's the thing. If I were to end this problem right now, I would recognize that my milliliters would cancel, and the unit I'd be left with is liters. So I can't end here. I'm trying to get to cups, not liters. So what does that mean? That means you have to add another conversion. All right, so you have to add a whole nother conversion, a whole nother bracket there. So we got to add that. And so now I'm at liters, but where do I go from here? Well, I have a conversion between liters and quarts. So I can put that into this conversion now. All right, and again, the question is what goes on top, what goes on the bottom? Well, I have 1 liter is 1.0567 quarts. Since I had 1 liter up here, I'm going to need to have my liter on the bottom now. All right, so my 1 liter to 1.0567, and I'll abbreviate quarts with a QT like that on top. So now, since my liters were on the top and the bottom now, I can cancel those out. So now if I finished, my answer would be in quarts. And again, I can't finish here because I'm trying to get all the way to cups. So guess what? I got to add a whole another conversion. So let's do this. I got to go from quarts to pints now. All right, well, you're starting to get the hang of this. What goes on the bottom? It's going to have to be quarts because I need quarts to cancel. So 1 quart is 2 pints. And now at this point, I've got my quarts canceling. All right, and then I've got one last conversion to get to cups, and that's that 1 pint is 2 cups. So I got to draw one last conversion, and that's that 1 pint, and I put that on the bottom because I need pints to cancel, to 2 cups. All right, so catch this. After I did all those conversions, all right, I recognize that the only unit that is going to end up being in my answer is cups. Where did cups get canceled out in the problem? The answer is nowhere. So that must mean that cups will be in my answer. Every other unit you can see was either on the top or the bottom, okay, at one point. That means they're going to end up canceling out in the end. So instead of multiplying all those units and putting that in my final answer, I'm just going to cross them out as I go. So since milliliters on the top there, cancel it out. Same thing with liters, same thing with quarts, same thing with pints. So my answer is just going to be left in cups, all right? Now here's the math part. What I do is I got to multiply the tops and divide by the bottoms. So in my calculator, this is what I do, and this is what you should do as well. You're going to multiply across the top. So 2,000 times 1 is 2,000, times 1.0567, times 2, divided by 1,000, divided by 1, divided by 1, divided by 1. And when you press equals, you will get your answer. So in this case, it's 8.45. And then what's my unit? Cups. All right. So again, that's kind of like a long problem. And you can see, well, I thought I could do this kind of my own way, but now that it's getting more and more complicated, I see why we're canceling out units. All right. So this is an example of a much longer problem where you got to go from one that's on your sheet that it doesn't give you the direct conversion. You kind of have to find your way there. All right. But this is the essential setup for dimensional analysis. Okay. Does it get harder from here? The answer is yes, it does. Okay. So before we just had one unit on top. All right. Let's say that we're given a rate. So we have a unit on top and bottom. For example, what is a rate? Well, that means that I'm going a certain speed, like miles per hour, or maybe a pipe is bursting water at some sort of gallons per minute, something like that. Well, that changes things a little bit, and you're going to see here. Well, let's say that I'm going 200 miles an hour in my Hellcat, and I want to convert that to kilometers per hour because I'm in Canada. I don't know. So I need to go from miles per hour to kilometers per hour. All right, well, I notice a couple of things. I notice that my hour, my per, okay, is per hour in both of those. So I don't need to convert my hours because it's in hours in both of them. But what do I need to convert? My miles to kilometers. Well, here's the thing. Can I do that? Well, let's go back and let's look at our conversion chart. Well, we actually already did this. We converted between miles and kilometers. 1 mile is 1.609 kilometers. So just like before, I'm going to write down that conversion. 1 mile equals 1.609 kilometers. All right, fair enough. I think that's all I need. So how do I set this up? Again, it's going to be the same way you did it before, except it'll look slightly different. 200 miles per hour. I'm going to write that first. 200 miles. But instead of just having this on the top, now since it's a rate, I have something on the bottom. What do I have on the bottom? 1 hour. Because think about it. If you're going 200 miles an hour, you're going 200 miles every 1 hour. So yeah, you do have to include that one. Okay, so 200 miles on top. And since it's per hour, it's 1 hour on the bottom. Okay. And just like before, now I add a conversion. I add a little fraction here. And the question is, okay, what goes in there? Well, it's the conversion that I need. I have 1 mile equals 1.609 kilometers. And so which goes where? Well, I'm trying to cancel out my miles. I'm trying to keep hours. I'm trying to cancel out my miles. So if I'm trying to cancel out my miles, that means that I need to put it on the bottom. So I'm going to take that 1 mile and I'm going to put 1.609 kilometers up top. All right. And so, well, what happens to my units? Well, since I had miles up top here and miles up top or on the bottom there, they cancel. So what unit am I left with? Well, the only ones that did get canceled are kilometers on the top and hours on the bottom, which means my answer is going to be in kilometers over hours or kilometers per hour. Well, shoot, that's what I want. That was my goal. So really, this is all the math that I needed to do. This is all the work, all the setup. So I can just go ahead and complete this problem. I can multiply across the top 200 times 1.609, and you get about 322. And my unit is kilometers over hours, or kilometers per hour. So even though it looks a little bit different because now it's a rate, the setup is still the same. All right, you just put the rate, whatever it is, underneath. Okay, so it's 200 miles. 200 miles per hour is 322 kilometers per hour, and that's the setup. Okay, well let's do one more. All right, and so this is kind of the apex of what we will be doing, and this is how hard it's going to be as far as dimensional analysis goes. All right, so let's take a look. We have 90 gallons per hour, and we want to convert that to quarts per minute. All right, so looking at that, I recognize that I need to not only convert the top, the gallons to quarts, but I need to convert the time, the hours to minutes. Okay, fair enough. So I'm going to make a lot of different conversions here. Well, what does this look like? Well, gallons to quarts. All right, I'm gonna do that one first. What's my conversion between gallons and quarts? Well, I'm gonna look on here. Well, I got 1 gallon is 4 quarts. All right, so I'm gonna write that down. That's good. 1 gallon equals 4 quarts. And then I'm trying to go from hours to minutes. Okay, that is on your sheet, but hopefully by now you know how many minutes are in an hour. So I'm just going to go ahead and write down that 1 hour equals 60 minutes. Okay, so now I think I have my conversions. I think I know what I need to do. Question is, how do I set it up? Well, remember, you're going to set up every problem the same. You're going to set up it starting with what you're trying to convert. I'm trying to convert my 90 gallons per hour, or every 1 hour. And so that's what I start with. And then I need to multiply that by a conversion. Well, which conversion do I do? Do I do the gallons to quarts first, or do I do the hours to minutes first? And the answer is it doesn't matter. Whichever one you do first is not going to matter, because in the end, the math all works out the same. So shoot, let's do a weird one first. Let's do the hours to minutes first, okay? Well, if I'm trying to cancel out my hours, all right, in this problem, this is the first problem that we have like this. If I'm trying to cancel out my hours, where do I put this conversion then? Where do I put hours on the top or the bottom? Well, I put hours actually on the top this time because it was on the bottom here. So this is the first one where I'm actually putting the hours on top. I'm putting it in a place where it doesn't normally go. Usually I'm used to kind of putting it on the bottom right off the bat, but here I'm trying to cancel out my hours. So the way I do that is I need it to be on top. So I'm going to put that 1 hour on top over 60 minutes on the bottom. Okay, so let's see what just happened unit-wise. The units that canceled were my hours. So if I were to finish this problem, do the math, what I'm left with is gallons over minutes. Okay, so I can finish this and get it in gallons per minute, but I'm trying to get quarts per minute. All right, but at least I got it into minutes. All right, so now I'm going to use my other conversion. I need to make one more conversion. And so I'm going to use the one down here, my gallons to quarts. And I'm going to plug that in. Question is, where do each of those go? Well, my gallons were on top up here. So that must mean that if I'm going to cancel out those gallons, I need to put gallons on the bottom. So I'll put 1 gallon is 4 quarts. All right, so now what happens is, since I had gallons on top here and gallons on the bottom there, they actually cancel. But Mr. Cutler, they're not right by each other. The parentheses are way over here, and my gallons are way over there. Doesn't matter, because if you multiply them across, you're going to end up canceling them out anyway. It doesn't matter where they are in your final problem, they're going to cancel out. So keep that in mind when you're doing this. When some of these hard problems, is that it doesn't matter that gallons is all the way over here. As long as it's on the top somewhere and on the bottom somewhere, they're going to cancel out in the end. So you're allowed to cross them off. Okay. So looking at the units that didn't get canceled, I have quarts on top and minutes on the bottom, which means that my final unit, will be in quarts per minute, or quarts over minutes. All right. So now that's left for me that I got to do is the math. So now I multiply across the top, 90 times 1 times 4, and I divide by the bottom, divided by 1, divided by 60, divided by 1, and the answer I get is just 6. Okay, so 6, and then what's my unit? Quarts over minutes, or quarts per minute. Okay. So that is dimensional analysis. Dimensional analysis is just the skill of being able to convert units from one to another using this format. Because later in chemistry, we start working with moles, and then it's this whole world called stoichiometry. And that sounds even scarier. But in order to make that manageable, we need to learn how to do it this way, in ways in units that we understand. So that is why I'm teaching you this in this format, is because it's actually going to be a tool that we use later. But let me know if you have any questions. Hopefully this video was of use to you, but that's going to be it for dimensional analysis that we learned right now.